All right. So basically, when you type something in ChatGPT, right? Say, for example, you ask something in ChatGPT. So, say, what is the color of sky? Let's say, okay, we almost certainly say that it is going to be blue, light blue, right? But as far as the AI is concerned, it doesn't work that way. When you are doing something in a deterministic system, what do you mean by deterministic? The results are always fixed. Okay. You have something, uh, say, for example, you have designed a machine that actually, uh, I always take the example of mixer grinder in my classes. Okay. If you have designed a machine that is designed for the purpose of, say, grinding something, it is almost certain that when you put in something, that content, that whatever you put in is going to be ground to the powder, right? So if you have designed a machine to, say, heat something up, when you turn it on, you are 100% certain if it is working properly, then you are 100% certain that it will heat up, right? So, or say, for example, take an example of water tap. You have taps around the house. When you turn on the tap, you are 100% sure that you are going to get water, nothing else, right? So when such systems are designed, those systems are actually called deterministic systems. So you can predict the outcome of that particular system with 100% certainty. It always does that. There is no question that whether it there is a possibility that it doesn't do the work that it is designed to do. Okay. Almost all the engineering systems have been like this. You design a car, the car always is supposed to run. Okay. On the road. It is not going to fly anyway, ever. So these are all called deterministic systems. But deterministic designs saturated at a point, like they were not sufficient enough to model the real world, because real world doesn't give you 100% certainty in 99.99 of the cases. The outcome can be anything. It looks like it is random. You cannot be sure. Hell, you can't even say for sure that you are going to, or we are going to wake up tomorrow morning, right? Anything can happen. That is the nature of the real world. So to model a real world into a system that we have designed, like a computer system, something else was necessary. And that concept was the concept of probability. Okay. So when we are talking about AI, say ChatGPT, I told you that when you ask something to ChatGPT, say what is the color of sky, right? The language model that it is using, it tells you it is going to be blue. But internally, in the mechanics of ChatGPT, what it is essentially doing is actually calculating the probability of being blue. Okay. Or what are the probabilities of a color associated with sky? Whichever is the highest probability, it will give you. Okay, highest probability comes out, if it comes out with blue, it will tell you blue. However, the same question you ask ChatGPT in a little different way, say what is the color of sky during sunset? Okay, then it looks at the data that it has. In the majority of the cases, the color is going to be red or golden, right? Then it is possible, since it has higher probability associated with that color, it tells you it is going to look golden or reddish. Okay, so that is how the AI works behind the curtains, we can say. Fine. So the understanding what probability is, and how it is implemented inside an AI engine can really help us to understand uh, the mechanics of any AI system, for that matter. Okay. So for that reason, I have included this concept. However, for the rest of the exercises that we are going to do in the remaining 4 days, we will not be using probability much. Okay. Then what is the probability? Probability essentially is an observational science. Okay. Why observational science? It is totally dependent on the observations that we have carried out so far, right? Whatever data we have or whatever information we have gathered so far, based on that, we decide the likelihood of anything happening. Okay, for example, most of you have must seen that if the weather is cloudy since morning, okay, or if the weather gets cloudy afternoon, there is a higher chance that it is going to rain today, right? That is something that we actually do, correct? Just give me a moment. Yeah, sorry. Correct. What was I saying? So if it gets cloudy in the afternoon, means what? There is a higher chance that we are going to get rain that day. So that is what essentially the probability is. Why we have come to that conclusion, or what makes us say that? It is because in many of the days, whenever there was a cloudy weather in the afternoon, it rained. So that is our knowledge, prior knowledge that we already had. That was based on our observation. We are saying now that if it is cloudy today afternoon, means there is higher chance that we are going to get rain. Makes sense? That is how probability was, the concept of probability was developed. However, simply saying that this is what happened in most of the cases, so higher chances are there, it is not sufficient to design a computer system in that manner or to analyze something specifically. So that is why we brought in the mathematical language into the probability, and we tried to formulate the observations that we have made, okay, and then use that formulation to solve for something, a number that can actually tell us with quantitative precision how much how high the chances are that we are going to rain today, for example, in this example that we have taken. Okay, just to make sense of it, let me write something like this. So say for example, in the previous year, or in the last, let us say, yeah, in the previous year, right, from January to say June, in this time window, right, I had observed and tabulated that there were totally cloudy days count. Say, for example, there were 50 cloudy days. Okay. Cloudy days, like afternoon cloudy. Okay. I'm just trying to fit the problem into the same example that we are using. So there were 50 days where we had the afternoon to be cloudy. Okay. And then we observed that out of these cloudy days, 50 cloudy days, it rained on, say, for example, 40 days. This was the sheer observation we made in the last year, let's assume. Okay, in the period of January to June, out of all those days, number of cloudy days were 50. And then out of those 50 days, we had 40 days where it rained. Now, if I ask you what is the probability, right, of it raining when the in any cloudy day. Okay, say for example, today it was cloudy in the afternoon. Then what is the chance that I will get a rain? Right? In that situation, what will you do? Out of 50 cloudy days, we had rain on 40 days. Okay. This ratio is what we treat as probability. How much is it going to be? How much is it going to be? 0.8, right? Correct or not? Correct or not? Yeah. So you are listening to the class, right? So now this 0.8, if I multiply it with 100, I will give me a percentage, and that is nothing but 80%. So now I can tell you, if it is a cloudy day, there is a 80% chance that it rains. Okay. However, uh, say for example, there was another observation that you made where the days were clear. Okay, you observed for maybe some 100 days, and out of 100 days, it rained, for example, how much? The same number, let me take 40 days or maybe 50 days, right? There is no condition of cloudiness or whatever. You observed for 100 days, out of 100 days, it rained, for example, for 50 days. Then, if I ask you randomly, okay, what is the chance of getting rain today? How much will it be? 0.5. That is nothing but what? 50%. Makes sense? Okay. What if the observation of was such that it rained for maybe 20 days out of 100 days? In that 100 days window, it rained only for 20 days. Then how does it affect the chance of getting rain? It will be like how much? 0. Point how much? 2. Cool. That means what? There is 20% chance that it is going to rain today on any random day. This is what our observation has brought us. And this is what our observation has brought us, right? That is why we say probability is basically an observational science. Okay. Now, say for example, there are 100 different items in a bag. Okay, which contains say not 100. Let's take some smaller number. Let's say there are 10 colors in a bag, 10 colored balls. Then what is the probability that I will draw a red ball? All colors are different. Okay. What is the probability that I will draw a red ball? Then how much is it going to be? There are 10 balls to pick from, right? And red color ball is just one. So what is the probability of drawing a red ball? Sorry, I said it is 10, right? Right. Red ball is in number one. So the probability is going to be 0.1. That is 10%. This is what we call a simple probability. Okay. Now, this is pretty simple, but it is not what we require for the purpose of AI, because AI simple probability calculation we don't even require in AI, right? It is pretty straightforward. You just pick out the total number of samples, you measure how many things were of the value that you want to, and then simply divide that number by total number of counts. You get the probability that is there. But when does it add value to an AI is by something called Bayes theorem. Okay. And this theorem talks about conditional probability. What do you mean by this? Seems scary, right? Don't worry. It is something like this. So out of these 100 days, getting a rain was 20, right? That means what? It is 20%. And out of 50 cloudy days, getting a rain was 40%, sorry, 80%. Okay. And having a cloudy day, maybe out of these 100 days, I observed that some 60 days, or let's assume 50 itself, some 50 days were cloudy days. Then what? 50%. Right now we have three separate probabilities. What are they? One is probability of cloudy day is how much? 50%, right? Probability of rain is 20%, right? Probability of rain on cloudy day is how much? 80%. So we calculated all this. Okay. Now on any random day, I want to calculate what is the probability of it raining provided it is cloudy. Or in the other way around, on any random day I pick, what is the probability that it was a cloudy day provided it rained that day, right? All these manipulations we want to do. Say, for example, I got the weather to be cloudy today. Now that is a given event, right? This one, this we know. It falls in this 50% probability, right? That the day has become cloudy. Now with that, probability of raining is 20%. So just like that, if I want to predict whether it is going to rain, I can be certain that with only 20% confidence, I can say it will rain. So I can say there is a 20% chance that it is going to rain. But however, if I am given with a new information that it is cloudy already, then what happens? Then it should increase to 80%, right? Makes sense? Okay. In the same way, if I ask you that it rained today, what is the probability that it was cloudy? Right. So that is another possibility. Correct. So how do you calculate this? This has become a new information. With this new information, you will have to update the probability of something else. Okay. So for that, that is what conditional probability is, because we are given with the condition. Okay. Based on that condition, given an event already has happened, what is the probability that another event associated with is likely to happen? Okay. Now, when you ask an AI, for example, what is the chance of me passing the class? Say, for example, maths class. Okay, I have studied so and so, so and so. This is um, uh, this is something um, you need to predict whether I'm going to pass or not. What is the probability that I will pass this exam? You ask the AI. What it does, it simply calculates the probability based on the sample it has of general population. Okay. It gives you, say, for example, there is a 60% chance based on the topics that you have given that you will pass. Okay. Now you tell the AI in another in the next prompt, you tell it that I have never failed, right? I have say, yeah, I have never failed so far in any math test. Now this is a new information that you are giving to the AI. So now it will use this information, right? And then recalculates this probability. And obviously, since you have not failed in any math so far, that means what? There is a higher probability that you will pass this particular exam too. So maybe the probability increases to, say, for example, 75% or maybe 95%. I don't know. Makes sense? This is where you apply the conditional probability concept. Okay. So now, what is the formula here for Bayes theorem? What is the probability of an event A happening given B has already happened? Okay, is equal to something that we already know, probability of B given A has happened. This is our prior knowledge. Okay, into probability of event A occurring divided by probability of event B occurring. This is the formula. Don't worry about the formula. If you can't remember it, it's totally fine. Okay. So in this example, if you take it, can we relate it? What is the probability of, say, let's name event A as cloudy event, B as rained event. Okay. Now, what is the probability of the day being cloudy given that it rained? Cool. Now, probability of B occurring given A has happened. What is this? A is cloudy. So probability of it raining given it is cloudy, right? We already have this 80%, right? What is the probability of a day being cloudy? Here we have what? Probability of cloudy day. We have 50%, right? And then what is probability of B? What is the probability of rain? It is going to be 20%. Correct. So with this, we can actually calculate what? This value, right? So with this, if I have to plug in the values from percentage, let me convert it into the decimals. 0.8 into 0.5 divided by 0.2. It's going to be what? 0.4 divided by 0.2 is equal to what? How much is it going to be? Oh, sorry. Did I make a mistake here? Yeah, I missed something here. Yeah. The mistake here is that data is inconsistent, right? Because out of 100 days, here in this example, right? If you look at it, cloudy days were 50, right? And then it rained on 40 days. This we calculated properly. But here we took only 20, and it should have been a little more, right? It should coincide with this, right? This one also we calculated with respect to this number, but this number is not proper. While taking the example, I made it 20. So let's make it say 60. And how much is it? 0.6, 60%. Right? Now, how is it going to affect these two remain the same? This is actually more. I hope you understood what it is, the problem, right? We had taken 100 days window, and out of 100 days, 50 days were cloudy here, right? And then out of those 50 days, 40 days were supposed to be the days where it rained, right? That consistency should be there. And out of these 100 days, it rained in total 60 days. There were certain days where it was not cloudy and yet it rained, right? Apart from these 40 days, we also had some more days where it actually rained, or we can actually make it 50 also now. No issues. Just for our understanding, it is good enough. Okay, why I did that, you will come to know. So this is going to be how much? 0.4 divided by 0.6, right? 0.666 or 66%, right? So this is what it is. Now, how much was the cloudy day thing? 50%, right? From a simple calculation that a day being cloudy, the probability being 50% here. Now, given that it rained that day, the probability has increased to 66%. Correct? This is what conditional probability is. We will uh, calculate the same thing using a data set in Python as well. I hope this makes you understand the concept, what it is. Is it clear? Okay. So one lesson that we must have learned from this, I know you are new to this, is that the data has to be consistent. You cannot take some random numbers. Why? Because the probability value, right? Whenever you calculate the probability value, it should always lie between 0 to 1, the range of probability. Okay. This is the standardization that we have. Because when I told you about the red ball being drawn from 10 balls, always the bottom part is the sample space where you can pick the data from. And the above one is always the part of this particular space, right? So when that means what? The numerator is always going to be less compared to the denominator. So you usually get some fraction, always less than 1. Okay. When does it become 1? When this becomes 10. What does it mean? What is the probability that you will pick all 10 balls? Or you will pick 10 balls. What is the probability that you will get all colors? Obviously, full, right? Only 10 balls are there. You pick all 10 balls. You obviously get all 10 colors. Then the probability will become what? 1 in this situation. Okay. You have some 10 colors and you are trying to pick a ball which is of a color which is not present in the bag at all. In that situation, what is the probability? It is going to be 0 because that is not in the sample space at all. Make sense? Then actually it becomes 0, right? The result is also going to be 0. So the probability of an event that is never going to happen is 0. The probability of an event that always happens is going to be 1. So when the simple example people take whenever teaching probability is what? When you flip a coin, what is the probability of getting a head or tail? How many sample spaces are there? Two. A head or tail. What is the probability of getting a head? You are picking any one, right? It is going to be zero point 0.5. So if the coin is neutral or not biased or balanced, then there is a 50% chance that you will get a head. Or the same way, there is a 50% chance that you will get a, okay. So I will stop here. This particular formula, right? This concept of Bayes theorem or the conditional probability, it is basically used to predict the categorical items. Categorical, we already discussed what is a categorical data, right? Say yes or no, right? For example, uh, if I tell you placed or not placed, these kind of data, they have a sure event where either they are placed or not. So in these kind of predictions that we need to do, we generally make use of the Bayes theorem. Okay, there is a classifier called the ML models that predict these things. The categorical values are called classifiers. Okay, and the out of these classifiers, there is something called Bayesian classifier. This is one of the models, and this basically completely makes use of Bayes theorem, conditional probability. Okay, what is the probability of the person getting placed provided he has completed his master degree, for example? Okay, so I will stop it at that. Hmm. Then let's do one thing. Let's do this part in Python collab. Then we will come back to the other concept called R square metric. We will wind up the probability part and then come back to the R square metric of statistics. Okay. That is important for tomorrow. Is it okay? Shall I stop sharing this screen and move to the collab? Second, where is it? Yeah. So for this example, what I will do, I will take a data set that is already present in one of the libraries. Okay. All these things we did yesterday. Yeah. I hope it is visible to everyone.
Yes, sir.
Okay. So pandas, we have actually not seen anything yet, but like I said, it is not about pandas, right? It is a library specifically designed for data processing, okay, and manipulating different types of data that you can import from any data set that's already there. And then NumPy, we already know. Seaborn is something that actually is for visualization. Okay, it is more like it is used more for drawing graphs and everything. But however, it contains some data sets inside it, inside the library itself, some standard data sets. So what I am doing, I'm trying to make use of uh, a data set that is of Titanic. Okay, what is this? Let's look at the data. This and in pandas, whatever you load, right? The data that is in the form of data frame. So if I simply type what type of data it is, please understand, I'm not trying to teach you this one. See, right? It's a data frame object. Just give me a second and put my laptop on charge. Yeah. Cool. What does this data, particular data contains? What is it? Let's see. Yeah, this is the data that we have inside the Titanic data set. Okay, what is it? The survived, 0 means dead, 1 means true, survived, some passenger class, 313 something, sex, male, female, age, what the age was. So it is basically the passenger list in the Titanic ship that actually sunk, right? We already know that story. So the gender, man, woman, okay. Adult male, true, false, okay. Deck, embark, whatever. Alive, no, yes, yes. The same data is being replicated here as a categorical value. Okay, no issues. For this particular example, we need only this one and maybe this one. Okay, let's take these two columns. Okay, so let's do one thing. First, let's find out how many passengers were there. So this is going to be our sample space, right? So total passengers is equal to data of, sorry, length of data. And this is something as the syntax is something that is uh, related to pandas library, pandas data frame. Okay, let's just take data and then print the passengers. How much are there? 891. So in total we have 891. We had yeah, we have 891 people mentioned in the data set. Fine. Okay. Now let us see how many actually survived. We have this column here, right? Survived column. We can take this. Let's say total survived equal to data, the survived column. Okay. This we took. Then what do we need to check? Whether it is true or not. This essentially gives us, we need to put this right, total survived 342. Out of how much? 891. Out of 891, 342 people actually survived, right? So now, if I ask you that when I pick, if I pick some random passenger from the list, what is the probability that that person has survived, right? Then what is it going to be? Probability of survival. So if I calculate this, P survived is equal to how much? Total survived, right? Divided by how much? It is the number of passengers. So total passengers. So if I print this, print P survived, it is 38.38% or 0.38. Understood? This is the calculation of simple probability. Understood or not? If you are unclear about the code or whatever, you just keep doing the same thing along with me. You can do that. If you find something difficult, you can just ask. Understood? So now I'll change the question that what is the probability of that person, say, is a female, right? Given that that person has survived. right? I pick a person. I just look at the survived column. If it is written one here, right? That means say, for example, I pick this person. Survived column, I have one. Means what? The person has already survived. What is the probability that that person is female? If that is what I wanted to calculate, then what can we do? So I need to calculate if I pick somebody randomly, what is the probability that the person is a female? That probability I need to first calculate. So to do that, what should I do? Total females I need, right, is equal to what? Let me keep it simple for you. So I will use the same formula, length of, okay, data of the symbols is equal to female. Yeah, 314. So there are total 340 number of females on the ship. Okay, so then what is the probability of a person being female? P female, let me write, is equal to what? Total females divided by total passengers. Make sense? So if I print this, let's annotate if we want. I hope you are able to calculate, follow up. I'm just omitting the descriptive words here, printing away the values. So when I pick somebody randomly from the list, the probability of that person being female is 35%. In the same way, if I pick somebody from randomly from the total sample, the total list, the probability that that person has survived is 38%. Okay. Now we need to calculate the what? The probability of a person being a female given that they are survived. So that is what we need to calculate, right? So shall we do that? I hope you were able to calculate this much. So no, please let me know once you are done with this. Okay, 1, 2, 3, 4, 5, 6 people. How many are there in the meeting? 10. Just leaving out me. There are 3 more. Okay. Majority of you got the result, right? So now let us do this. What what is the probability, right, of a person being female given that they have already survived? So for that, what we need to do? We need to extract the count of females, right, from the survived list and then calculate the probability. That is the idea, right? So let's do that. Let's do one thing. This statement that I'm going to write, survivors. Here, what we are doing actually is limiting the data set to only those who have survived. Okay, so data of survivors survived, right? Yeah, sorry, survived is equal to 1. So what is it going to look like? Now, if you look at this, the new data frame where I have only picked those who have survived, right? You can see the survived column contains only ones, correct? This is the list of, if you look at it, 342 rows, correct? 342. So we have shortlisted only those who have actually survived. So survivors count, we already have total survived. And in this, if we need to calculate the probability of it being a woman, then what is it going to be? Females survived is equal to length of survivors. Okay. And then so it's equal to this 233. So 233 females survived, right? Or we can say out of 342 who actually survived, it was 233 females out of that number, right? Now, if I want to calculate the probability of a female surviving is how much? Females survived divided by total survived. Correct? If I'm given with the assurance that I'm picking somebody from the survived list, then the probability of picking a female is this much. P underscore female survived. So it is going to be 0.68. Correct? So basically, what are the things that we have calculated? We have calculated probability of survival of the people, right? And then probability of a female, right? Probability of somebody being the female, and then probability of it being a female given they have survived. right? This much we already have. Is it clear? Now, if I want to plug in the Bayes theorem, okay, what is the Bayes theorem here? Okay, it's clear, right? Clear? Only one or two less said, no issues. I hope you are able to follow. If you have any doubt, you can just pitch in. Now, using the Bayes formula, I want to find out something else. What is it? If I ask you, uh, if I say, what is the probability of picking someone, okay, who has survived, given that the person is female? It is the opposite. So here we have did what? We have calculated the probability of the person being female, given that the person has survived, right? Now I want to calculate the other way around. Given that the person I am picking is a female, what is the probability of them having survived? The other way around, right? So to calculate that, what should I do? P of survived given female. Okay, is equal to what? Using the Bayes theorem, P underscore female female underscore survived, right? Multiplied with what? P underscore survived, correct? Divided by what? P underscore female, right? What will be the value? 0.74%. Sorry, 0.74 or 74%. Any doubts about this? So now what is the new information here in this? Sorry, no, sir. What are you unclear about? What are you unclear about? Now, okay, let me explain it in another way. All right. Deepak, okay, please type away, man. Bayes theorem. Okay, cool. Let me simplify it further. Okay. Out of the entire samples of the Titanic ship, right, passengers list, we calculated what is the total number of people, total passengers we calculated. Fine, no issues. That is a sample space that we have. Okay. And then we calculated how many people actually survived from the Titanic crash, right? It sank in the ocean. I hope you know the story. So, with this information, out of this many passengers, this many have survived. So, the probability of a person surviving, if I pick somebody randomly from the list, the probability that the person has actually survived the sink, right, is how much is what we have calculated here using this P survived probability. Okay, how much is it? The first value that the first, second, third value we printed, right? It is 38%. So if I pick somebody from the passengers list randomly, the probability of that person being survived is 38%. Okay. Now, if I want, I have another information that total females are this much. So probability of the a person being female, I can calculate using the data set that is already there, right? And then out of that, how many females were had survived out of the survivors list? If I want to calculate the probability of picking a female, if I calculate this, what is this information here? It is the probability of the person being female given that they have actually survived. Okay, this is something we actually calculated. With all these values, is it possible to calculate how many, what is the probability of a person being or of a person surviving given that the person is female? Okay, this much is something we already know, all this much. Now, if I pick somebody randomly, the survival probability is how much? 0.38, that is 38%. Now that I have a new information that the person is female. Okay, this is a new information now that we actually have got. With this new information, is it possible to improve my probability is the question. How does it affect my probability about the survivor? Okay, I'll give you one simple other example, but let me finish this. Now to calculate that, Bayes actually gave this formula. What is it? We use this particular formula where this probability gives you that the person being female given that they have survived. This already we know, so we use this. And along with that, we multiply we survived. What is the probability of the survival? That is the information that we already had. That is 38%. And then that is normalized over the probability of the person being female. Okay. Don't worry about the nuances of the formula. It goes a lot more deeper. Okay. But just understand that knowing these three, I can actually update my this particular value. This is the core idea that we need to understand. Okay. Now, if you look at this, right, from P survived being 38%, once I have the information that the person is female, a new information, now the probability has increased to what? 74%, right? Just to show you the mathematics, I have picked this particular data set. To make you understand the concept, let's take another one. Say, for example, what is the probability that an email that you get is a spam? That is the simplest example I can give you, and you can find it anywhere. Okay. So, what is the probability that an email that you have got is a spam? Okay. Maybe out of 100 mails, you have got 30 spams. Okay. Now, the probability is going to be 0.3, 30%. However, if I mention one more information that in the subject title, say for example, you won a lottery, in the subject that they have mentioned, you won a lottery of 1 million, let's say. Now that this new information is given, what is the probability of that email being spam? It is going to be way, way higher, right? Most of the emails that you must have got would have contained some wordings related to lottery, amount, money, or whatever. So the moment I see lottery in the subject title, the probability of that being the spam becomes more. That is the intuitive analysis of or the application of Bayes theorem. That is actually how your spam filters works at the background. Now I hope it makes sense. Cool. You do one thing. I know it is a little complicated subject. That is why I actually have allocated more time to this to explain this. But I don't know how much you were able to understand properly, right? In that situation, what can we do? Let's keep it at that. Let's do one thing. You guys must have done this calculation in your collab, right? Just go through this calculation. I'll share the whiteboard as well. So just go through the class once again. Try to understand it. If you were not able to make sense of it, right? Just ask in the WhatsApp group that, okay, it still is not clear. I will arrange a little more time for this particular concept in the next coming sessions somewhere. Seems okay? Is that okay? Is it okay? Okay. I think we are almost up the time. Now, should I really be going towards the R square metric or shall we start it tomorrow fresh? Okay, let's do one thing. We don't have sufficient time to cover the R square metric completely, and it is again shifting your focus from probability to statistics. So let me do one thing. I will wind up here. If you have any specific question, ask away. I will try to explain if it is possible in the next 10 minutes, or we can wind it up here itself. If you don't have any doubts, you can just drop away. And one more thing, where we need to discuss about linear regression and then one more component along with it. Okay, that is called gradient descent algorithm. So these two are very important for even if you go for an interview, you will need that.